now you should be ready for chapter 10. And in chapter 10, we're going to deal with exponents, we're going to deal with scientific notation, so we're going to have to be good with powers. And I know you look at me and say, I could see plenty of power there, sir. Well, let's learn a little bit more. This is called a power. The number here, the large number, is base. The exponent is how many times you multiply the base to itself. So 2 to the third power is the same as 2 times 2 times 2. That's what a power is. And in this chapter, we're going to do a lot with powers. So, if I wanted to write each of these as a power, I do the opposite of what I just saw. I have 6 times 6 times 6 times 6 times 6, which is 5 of them, so 6 to the 5th power. I have x times x times x, rest in peace, times x, that's 4 of them, x to the 4th power. I have 2 times 2 times 2, 2 to the 3rd power. And this is a little weird, 4 is on the bottom. That's okay. 4 times 4 on the bottom is 4 squared on the bottom. And then I just have 1 up top. You're allowed to do that. It's not against the law. So that's how I take something that's already ripped apart and write it as a power. What if I have things that are written as powers and I want to combine them? Well, do what we just did. Rip them apart and put them back together. So 5 squared is the same thing as 5 times 5. That's supposed to say 5, but it doesn't. Oh, my golly gracious. 5 times 5. What's 5 to the 4th? 5 times 5 times 5 times 5. How many 5s do I have? 1, 2, 3, 4, 5, 6. So that becomes 5 to the 6th power. I went from 5 squared times 5 to the 4th, and it became 5 to the 6th. I know you're thinking, well, why doesn't it become 25? Because I'm just grouping a bunch of 5s. Well, why doesn't it become 5 to the 8th? Because I don't have 8 5s. I actually only have 6 of them. So this is extremely similar. In fact, if you can look at the top one, you should be able to guess what the answer is here. But I'm going to show my steps anyway. 2 squared is 2 times 2. The lag on this computer is awful. Times 2 to the 4th, which is 2 times 2 times 2 times 2. How many 2's do I have? 2 to the 6th, because I have 6 2's. You might be looking at this and saying, I think I understand a shortcut, sir. And if you understand a shortcut, good. That's what Chapter 10 is all about when we get to Chapter 10. But we're not at Chapter 10. We're getting ready for Chapter 10. So, look at these X's. So many X's, it looks like it's my dating history. Because of X's? Because of the people I've dated? X to the 4th is X times X times X times X. X to the 1st is just 1X. And X to the 3rd is X times X times X. Rest in peace, June 18th. So how many X's do I have? 1, 2, 3, 4, 5, 6, 7, 8. 8 X's. Doesn't sound like my dating history at all. Sounds like a lot more than my dating history. Oh, I have 8 7s. Oh, I'm going to write out all of them. 1, 2, 3, 4, 5, 6, 7, 8. And next to it, I have 4 more. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 7 to the 12th power. I wonder if there's a faster way that I can go from 8 and 4 to 12, or from 4 and 1 and 3 to 8, and from 2 and 4 to 6. Probably not. Probably there's no mathematical shortcut here. Write as a power. Well, these guys are just kind of their own thing. So I'm going to multiply those together, 12. I have 10 squared, and I have 10 to the 4th. 10 squared is 10 times 10. 10 to the fourth is 10 times 10 times 10 times 10. How many 10s do I have? These 10s, there's 6 of them. So I have 12 times 10 to the 6th power. That's called scientific notation. But we're not there yet. We don't know what scientific notation is. We haven't learned it. So let's just leave that on its own. Prime factorization is when you take a number and completely rip it apart. Kind of like what we did here. When we took these numbers and completely rip them apart. Prime factorization is when we take a regular number and completely rip them apart. So 3 is just 3 because 3 is already prime. 12 is 3 times 4, or 3 times 2 times 2. So I'll actually write out 2 times 2 times 3. Now, you learned back in the day that if you have a number in the numerator that's the exact same as the number in the denominator, you're allowed to cross those out. When I cross those out, I'm left with nothing in the numerator, so I have to put a 1 there. 2 times 2 is 4. It's simplified. So I know I could simplify by saying, I could just divide the top and the bottom by 3. That's fine, but I'm approaching this using a different method, and a method that might be more convenient when we get to chapter 10. Maybe. 24 is 2 times 12, so 2 times 2 times 2 times 3. That's the prime factorization of 24. 16 is 2 times 2 times 2 times 2. If you have something in the numerator that's the exact same thing as the denominator, cross it out. And do it again. And do it again. And 3 over 2 doesn't cross out, so I'm left with 3 over 2. Leave your fractions improper. 8 is 2 times 2 times 2. As we know from a problem over there, 12 is 2 times 2 times 3. So let's cross a few things out. 2 over 2 crosses out, 2 over 2 crosses out, and 2 over 3 doesn't cross out, and that's what I'm left with. Okay? All right, last page. Oh, I wonder if we're going to apply what we just did to this guy. Probably. What's x to the 7th? X times x times x times x times x times x times x. What's x to the 3rd? X times x times x. Rest in peace, June 18th. If you have something up here that's the same as something down there, cross it out, cross it out, cross it out. Now, when I completely cross out an entire side, I have a 1 left over, but I wonder if that 1 on the bottom is necessary. I don't know. How many x's do I have up here? 4, so x to the 4th. Anything divided by 1 is that anything. So x to the 4th divided by 1 is x to the 4th. Not so bad. I wonder if there's a faster way to get from 7 and 3 to 4. Probably not. What's 4 to the 3rd? 4 times 4 times 4. And what's 4 squared? A fun game, but it's also 4 times 4. I have a 4 up here and a 4 down there, cross it out. I have a 4 up here and a 4 down there, cross it out. I have nothing left on the bottom, so we have to put a 1 there. I have just a 4 up top, and so I have 1 4. 4 to the invisible 1. I wonder if there's a fast way I can get from 3 to 2 to 1. Probably not. I don't know. You'll find out. That's it for Chapter 10. Should be ready to go. Bye!